All right, we're going to start one of our last topics here, and that's going to be quadratics. And today we're going to talk about graphing them only. So one of the things I want you to remember is that we've been working on graphing different functions pretty much all year long. We started in chapter 5 and talked about graphing lines. Then we did absolute values at the end of that chapter. And then most recently we did exponentials when we graphed exponential functions. And in all of those functions, we talked about how different parts of the equation change the graph. So if you look, here's all of our little general forms of our equations: the line, your absolute value, and then your exponential function. And for each of them, we want to think about, okay, how did the m change the function? How did the h change the function? How did the k change the function? Same thing in absolute value. How did h change the function? How did k change the function? H, k, etc. So think back to those sections, 5.3, 5.8, and then at the end of chapter 7, we did the Desmos activity where we graphed the absolute values to collect all those, the exponentials to collect all those stars. But how did each of those parts change the equation? What did it do to the graph? Did it shift it up, left, down, right? Did it make it skinnier? Did it make it wider? Did it make it upside down? All of those things are the things you want to think about. How did I change that function? So go ahead and do that. Think about that, and then do your Desmos activity, and then come back to this video. Okay, so let's talk about graphing quadratic functions, and we're going to talk about some of those transformations that you just looked at. Now, every quadratic function is a polynomial with degree of 2, and 2 is its largest degree. So if you look, you have anything with an x squared in it, and it being the largest part is going to be our quadratic. So x squared, 3x squared, 1/4 x squared minus 5, 2x squared plus 5 minus 7, those are all quadratic functions because x squared is the largest. Whenever you graph a quadratic function, since that's what we're talking about, then you're going to get a U-shaped graph, and that U-shaped graph is called a parabola. So the function is quadratic, but the graph shape is called a parabola. And let's go over a couple important parts of our parabola because we're going to talk about all of these parts in general. So when you have any U-shaped graph, you can see that red U that I got going. There's 4 important parts that we're going to need. The most important part in any form of graphing that we're going to do is the vertex. So the vertex is going to be that highest or lowest point on our U. So where does it start to change from increasing to decreasing? When we find that vertex point, we can call it the maximum if it's the highest, or the minimum if it's the lowest. And the other thing that does is tell us whether our parabola is open up or open down. So if we have a maximum, then that means the highest point is at the top, which means we know our U shape is open down, or it's a little sad. It looks like a little sad face. If it's a minimum that our vertex is, then that's going to be the lowest point, and our graph's going to be open up, or it's going to be happy. It's going to look like a little happy face. Okay? Things because it's static phase. And when we talk about those shifts, up, down, left, right, we're going to talk about where those shifts are for the vertex. Another important part is this axis of symmetry line that goes through the vertex. It's a vertical line through the vertex. If you remember, vertical lines have the equation x equals because they are going to go through the x-axis. So it's always going to be x equals a number. And that x equals equation is going to be a vertical line that goes through our vertex and divides our parabola basically into 2 symmetric halves. So one side is going to be equal to the other side. All the points on the left side will match up with points on the right side. Remember, symmetric, that means that one side is exactly equal to the other. And your face is a great example of symmetry because if you look, if you draw a line down the middle of your face, then your eyes would match up with each other, etc. So axis of symmetry is our next most important part. Then we have our y-intercept. That is going to be helpful. The y-intercept is going to be our point where our graph crosses the y-axis. So if you're looking at your graph, then at some point it's going to cross that y-axis, and there will be that y-intercept point. And then finally, the x-intercepts, where the graph crosses your x-axis, are going to be important as well. And they're going to be really important when we go to solve as well, too. X-intercepts also have a couple of other names, so you might see them referred to as a couple of other things. So we're going to talk about them referred to as zeros or solutions or roots. All of those words, x-intercepts, zeros, solutions, roots, they all mean these two blue dots right here. Where does it cross the x-axis? And as a reminder, each graph can have 0, 1, or 2 x-intercepts. So it could cross, maybe it only crosses once, or it could cross twice. So those are all our important parts on our graph, the vertex, axis of symmetry, and both x and y intercepts. Today, we're going to talk about vertex form. And vertex form is going to be the point or the form that we like as far as finding the vertex really easily, which is great, and it gives us lots of information. And if you remember all of those transformations, shifting up, down, left, right, it's going to make a lot of sense. So if you look at our vertex form, then you have the form of the equation y equals a times the quantity x minus h squared plus k. Remember, it has to be squared because this is a quadratic. So when we look at all of those parts and what do they tell us about our graph, the a tells us two different things. Number one, it tells us if it's open up or open down, or if it's happy or sad. If your A is positive, positive is usually a good thing. That means it's usually happy, so it's an open up graph. If your A is negative, so -3, -1, whatever, then that's a negative value, and your graph's a little sad, so it's an open down parabola. A also tells you if it's skinny or wide. So if it's a really fat parabola or a really wide U shape or a really skinny U shape, any big numbers, so numbers that are greater than 1, 1, 2, 3, 4, 5, etc., those are all going to give you a skinnier parabola. Any numbers that are fractions or decimals between 0 and 1, so 1/2, 1/3, etc., that's how you're going to make your parabola wider. The H, remember, tells you if you're going left or right, but remember with the H, you have to do the opposite. So if it's a positive H, that actually means left, and if it's a negative H, that means right. And then the K tells you how far up or down you're going with your vertex. So if the vertex is moved up 3 spaces or down 4 spaces, etc. So here we go. How do we graph in vertex form? We're going to first identify and graph our vertex from those H and K values. We're going to draw on our axis of symmetry. Then we have to pick a second point. We just make that point up and find its y value. That way we can graph it. And then we're going to use that symmetric property to help us graph that second point. So I have a little example here that I'm going to work out with you. So the first thing we have to do is identify that vertex. So if you look at my two numbers, h and k, this tells me the h is -1 and the k is -1 as well. Remember, h is opposite, so that means this is actually going to go right 1 space, and then k is not opposite, so that's going to mean it goes down 1 space. That means my vertex is going to be at +1, -1. So I'm going to go through and I'm going to find +1, -1 on my vertex or on my graph, and I'm going to mark that right there as my vertex point. So I do that just by looking at the graph. Okay. Now, I want to draw in my axis of symmetry. Remember, axis of symmetry is always a vertical line through the vertex. So I'm just going to draw my vertical line right down there on 1. Make sure it's labeled. So there's my axis of symmetry at x equals 1. Okay, and that really just helps me find that reflection point that we're going to do here in step 4. So step 1 was to find the vertex. Step 2 is to draw the axis of symmetry. Step 3 is to pick any other x value we want and find its value. So let's pick 0 because 0 is pretty close to 1. So I'm going to pick a value that I want that I know will be on the graph. And in this case, like I said, we're going to pick 0. So I'm going to plug in 0 here for my x. Okay, So we're going to pick 0 as our point to find our second value. And if we look for or plug that 0 point in, we're going to do 0 minus 1. That gives us -1. Square that and you get +1. And then that times -3 gives me -3. And then we get -1 in that value. And so you end up getting a value of -4. So you can see all of that work down here, where if we plug in 0, we end up with -4. So that tells me that my next point is 0, comma, -4. So I'm going to go through on my graph, and I'm going to graph 0, comma, -4 as my second point. Then we're going to use that axis of symmetry as our reflection part, or as the symmetric, and think about, okay, if it is one space away on this side, then its reflected point will be one space away on this side. See that nice symmetric, kind of like eyeballs for our parabola. So I graphed my second point here, and then I use that line of symmetry to help reflect it, and that's my third point. And then that's all the points you need to draw your parabola. So you have your vertex, that second point you picked, and then that third point that you reflected over or flipped over that green line. Okay? So go through, make sure you find your vertex, draw on your axis of symmetry, pick any other point relatively close to the first one. So remember, this one was at -1, so I picked 0 because that's pretty close. Plug that in, get your second value, and then flip that over the line. You will see down here that we are only going to be practicing vertex form today. So there's a bunch of vertex form practices right here. You can go through and practice all of those and check your answers before you move on to the next section next class. Don't forget, Math Excel is due on Thursday. That's your only graded assignment for right now. If you have any questions, don't forget to email me.